I think we're ready to start, so I will give the word to Trevor.
Awesome. Welcome. Thank you so much for attending this session. I'm super excited. I love talking refrigeration. I love talking about compressors. So thank you very much, Vanessa and Sergey, for the introduction. My name is Trevor Matthews. I started a company called Refrigeration Mentor to help train technicians, engineers, sales, project manager, really anyone who wants to get better at their jobs, better in refrigeration, their refrigeration career. And I spend a lot of time over the last 17 years learning refrigeration. I spent 10 years in the field actually working on commercial refrigeration, supermarket refrigeration, commercial, small commercial refrigeration, large commercial refrigeration, got into HVAC, did lots of stuff in the field. And I really thought I knew compressors, but was I wrong? Until I went and worked at Emerson, manufacturer of Copeland compressors. And I spent 7 years there just learning compressors inside and out, inspecting them, field support, helping technicians in the field. And that's where I really started learning about compressors. And it took a long time because I thought I knew how to troubleshoot compressors. I thought I was good at it until I started learning about them, and then learning about the other compressor manufacturers like Bitzer and Danfoss and Tecumseh and LG and Mitsubishi, and then really honing my skills on that because they work differently. Yes, a scroll is a scroll, but there's a lot of differences. And this is what we're going to talk about today. And I really want to share some of my knowledge. I'm going to just share my screen here if that's okay with everyone. So today we're going to talk about why understanding compressors is so important for troubleshooting, because when you understand how a compressor works and functions to a deep level, you're going to understand a whole system. And that's where you're going to really start to flourish in your skills in refrigeration troubleshooting, service, and installation. Because when you understand what happens inside that compressor and you look inside and you inspect it, you know what's going on in that condenser. You know what's going on in the evaporator. You know what's happening with the metering device. And it's so important to inspect these compressors. And what we're going to talk about today, well, I only have 30 minutes to chat. I could talk about 6 or 7 hours about this specific topic, just mechanical issues, but I got 30 minutes to try to share as much knowledge as possible. And we're going to review types of mechanical issues. We're going to talk about preventing repeat failures. We're going to get into a checkpoint review that you need to do every time you're doing a service call, every time you're commissioning a system. And this is important. You need to find sequence of operations and understand the sequence of operation, and then find your skills and find the way you really diagnose systems. So take information down, and you should be doing this the same way every time, so it gets into be a habit. So you're checking everything every single time, because what I've seen over the years, field support and thousands of technicians in the field, is that they do it differently a lot each time, or they don't get all the points. They say superheat's good. When you say superheat's good to me, and I ask you, okay, what's the pressure temperature? Well, it was good. That means you didn't check. I understand that you didn't check because I was there before. I've done that in the past, so I understand. You need the numbers. The numbers are facts. We're going to get into some mobile apps that you absolutely need on your phone or online, and then we're going to get into some educational resources. Okay, Vanessa, if you don't mind launching the first poll, I want to find out where everybody, if anybody has done compressor training before, a structured compressor program. So if you don't mind launching that, Vanessa.
Okay, I will launch.
Yeah.
Oh, thank you. So here it is. So when was the last time you attended a structured compressor training program? So have you ever attended one? Because this is very important. So never. So that's fair. I didn't either. I was 10 years in the field, and I never went to just a specific structured compressor program. And after I started learning and actually really training compressors, I seen the value of it. And a lot of my good friends, they own businesses for many years, and then they, after 15 or 20 years, went and took a deep dive compressor course, and they're like, oh man, I thought I knew a lot of this stuff, and really it's just showing up. So you reduce those repeat failures, you reduce callbacks, you're able to troubleshoot quicker and get the job and your customers' equipment up faster. Okay, awesome. There's, some of you have attended a training. Hopefully it went well. The ones that you didn't, that haven't, well, you're going to learn a few things here, hopefully. Okay, we'll keep moving on. We can stop sharing that.
Trevor, do you see result? The result of
so we got
on your
6
screen?
that did 1 to 3,
Please
4,
comment.
5+ years ago. So I'm going to stop sharing that, and then we'll share the results with everyone. That's okay. Okay, I'm going to close the poll. Thank you very much, everyone. So, types of mechanical failures. First, before I get into this, is you need to understand the compressors. And I do a full compressor training program that I'll talk about later. And I only have 30 minutes to talk. But they can see my screen right now, right? They can see me half the screen, Sergey?
Please.
Yes,
So right here, here's
yes,
the top
yes,
of a
I see.
scroll. So this is out of a Copeland scroll. Here's a floating seal. Here would be the bottom. So right here. So this orbits like this, and it squishes the gas. This floating seal right here pushes up when the compressor starts up, pushes up against the muffler plate that's right here. Oil seals this, and then this pushes down. It's axial compliance. And so that's how they go together, and it pumps the gas. Pretty straightforward. It just squishes the gas through each of the things to have a compression. So as you compress that gas, it increases the pressure, increases heat. There's heat of compression. If you haven't looked at an enthalpy diagram and understand it, because I didn't as a technician, I highly recommended doing it. I do a lot of CO2 refrigeration training, and it comes very in handy understanding that. So scroll compressors are hermetic. There are some that are semi-hermetic, but most of the ones that you'll see in the field are hermetic. And you need to understand that a lot of the times you don't know what's going on inside there because you can't look inside. You need to inspect it. You need to cut them open sometimes to figure out what the problem is. And if you don't, you may not figure the problem out. And you're not going to do this every time, but you're going to do it sometimes. And then this is a piston out of a semi-hermetic. So this is a piston. Here's the piston. This is a wrist pin. Here's the rod. And this pumps up and down. So this looks probably to you there, it doesn't look like a bad piston, but it is a bad piston because of a blown discharge. And we'll talk about that in a few minutes. But you need to understand these little tips and tricks, and you need to inspect compressors. If you're not inspecting compressors, you're just going to be a compressor replacer, and you're not going to figure out the problems. Because I've done it. I know I've done this many times. So do we have any questions yet, Sergey?
One moment, I will check.
Yeah, I don't see any. I'll keep going. Ask your questions anytime. So contamination is the first one.
No, we haven't yet.
Yeah, there's 6 types of mechanical failures, and we're not going to dive into electrical failures today, but 6 types of mechanical failures. Contamination is one of them, and contamination starts from day 1 installation. And if you do not install that system correctly the very first time, you're going to have failures. And it might not be in 6 months, it might not be in 1 year, it might be 2 or 3 or 4 years down the road because of that day 1 installation. Number one thing you need to do is make sure there is no non-condensable or moisture inside that system. I guess moisture, because moisture, water, heat, it causes something called, it causes acid inside the system with POE oil. And most systems now, like commercial refrigeration, have POE oil, and you're seeing it more and more with all the manufacturers, the new refrigerants. You have POE oil, and there's other blends of polyester oils, but when you add moisture to it, it causes acid because POE is made of acid. And then you can see right down here in, if you can see my thing right here, this is kind of what it looks like if you open up the compressor. So it doesn't matter if it's a semi-hermetic, if it's a hermetic compressor, and you start to see this. This is actually copper from the pipes that the acid pull away and bring it back to the compressor. So I know in this compressor 100% that there was moisture in this system or acid in this system. You need to pull your systems down below 500 microns or 6 M-bar, millibar, and that's low. But you need to do this, because if you don't, this is exactly what happens here. If you only pull it down to 2 bar, or if you only pull it down to, if you don't pull it into a deep vac, you're going to get copper plating. It happens. You're gonna, if you get moisture in the system. That's why you put sight glasses on the system, to see if you have moisture in the system. That's the whole point of a sight glass, is to see if you have moisture. A lot of people, well, it's to check your oil, your refrigerant level. Yes, it does that too, but it's really there to see if you have moisture in the system. Do triple evacuations, and you also should be doing purging while you braze. It's mandatory to be purging while you braze, especially with POE, because POE strips the copper, strips the pipes if there's any carbon on those pipes. So you need to be purging while you braze. It's important. And I've talked to lots of technicians, oh, I've been doing it for 20 years and I never purged. Well, that's why your systems don't last 20 years, 15 years. Because what happened with the POE oil, you might have got away with it with mineral oil for a long time, but with POE oil, you're not going to get away with that. Next, overheating. Overheating is one of the leading causes, and we're going to dive in. All the bold ones we'll dive into a little bit deeper. The ones that aren't bold, I'm just going to talk about them right now. But as you can see here, this valve plate is black, and anytime you can't rub the blackness off, that means it's major overheat. Major overheat due to many different things, and we'll dive into that in a second. But that is running real high superheat. That's running high compression ratio, and we'll talk about that in a few minutes. The next one, loss of oil. This one's a really hard to tell, especially if you don't have a sight glass. For example, this one has a sight glass. There's no oil in it. Where's the oil? So you need to understand if it's sloping back to the compressor properly. Are your lines sized properly? Do you have a trap? There's so many things you need to understand. And then after you remove a compressor, especially if it's hermetic, you need to check how much oil was in that compressor. Nobody's doing this, because I didn't do it before I worked for a compressor manufacturer. I didn't do it because I didn't know I was supposed to. But if there's no oil in that compressor and you can't find a leak, where's the oil? And what happens if you keep replacing compressors, you're putting more oil in the system, whereas logging all of a sudden comes back and then it smashes the compressor from a slug. And then you get continue repeat failure. So you need to figure that out. You need to measure oil and compare it to the manufacturer spec of oil. Let's see what else we got here. Flooded starts. This one is a big one. Flooded starts. How does flooded starts happen? Really, it happens through what we call refrigerant migration. That compressor's off. Compressor's the coldest part of the system. That refrigerant travels through the system as a vapor, condenses in the oil, and then when that compressor starts up, boom, you have a flooded start, or it leads to what we call a slugging. And slugging and refrigerant cool compressors are from major flooded starts. Slugging and air cooled compressors are from uncontrolled oil return or liquid floodback. And you need to understand the differences. This is so important because I didn't know before. I used to say compressor oil was liquid that caused that failure, liquid caused that failure, liquid caused that failure. That was me 10 years in the field, working on hundreds of compressors, installing, commissioning, and troubleshooting. And I just used to say it was liquid, or it's an electrical failure. Because the electrical failure is only 20% of the time. You'll go up to it and you'll ohm out the compressor or check the windings and, oh, it's dead short, turn to turn short, open windings. But that was caused from a mechanical failure 80% of the time, or a mechanical issue. And there could be 2 or 3 different mechanical issues that leads to that electrical failure. So you need to understand that. If you're going and just saying it's electrical failure or it's a burnout, you don't know what caused it, you're just going to be continuing to replace compressors. So you need to understand this. And then floodback. Floodback is another one that really is something that should be seen right away, should be understanding. And the big thing is, what's your superheat? What is your superheat? And if you say your superheat's good and you don't give me numbers, I'm going to say you don't know if it's good or not. You need to check superheat at the evaporator, and you need to check superheat at the compressor, because if you don't know if you have floodback happening. You know, you check at the compressor And if you have 0 degrees superheat, that's floodback. If you have 20 degrees or 11K, you know, you have superheat there. So you know there's no liquid happening. And then you need to understand the type of refrigerant you're using, because CO2 compressors are going to have different superheats, mandatory, compared to a regular HFCF, HFO compressor. So you need to look up this in the compressor manufacturer guides. So if it's Copeland, Bits, or Danfoss, they all write good manuals for their compressors. You need to dive into those ones. Okay, compression ratio. You see, I get pretty excited talking about this stuff. I could go for a long time, so maybe I have to get a warning from Vanessa. So compression ratio is so important to understand. As a technician, I never even thought of compression ratio. I learned about it in school, but compression ratio is so important, because if you have a high compression ratio, compressor's working harder, it's gaining more heat, and it's causing issues in your system, and it's system related issues that cause high compression ratio or design. So what is it? Absolute discharge over absolute suction. How do you get absolute? Okay, so in imperial units, it's you take your gauge pressure, 275 psi plus atmospheric, so it's 14.7. I just use 15, it makes it easier. 290 psi A. Then we get into the suction. Got to turn that to absolute. So 55 psi G plus 14.7, which I do 15, is 70 psi. So this is a 4-to-1 compression ratio. So probably pretty good for that specific system. Let's do it in metric. So if you have 19 bar plus approximately 1 bar, 20 bar A over 4 bar, say suction, plus 1 bar is 5. So now you got a 4-to-1 compression ratio. So you're okay, depending on the compressor, but that's usually what you're going to see in medium temp applications, high temp, medium temp applications. Now low temp is going to be a lot higher, but you do need to understand this, because if you have an increase in you got a dirty condenser and you have an increase in pressure, it's plugged up, you say you got a 25 psi increase. Okay, your compression ratio maybe go up 1 or 2. So instead of 4-to-1, it might be 5-to-1, we'll say. That's I'm using psi. But if you take that same 25 for these examples and then you drop it on the suction, you're like 10, 12 compression rate, 12-to-1 compression ratio. So suction pressure drop is real bad. And then if you have a high pressure drop in your suction line, either there's a design issue, you shouldn't have more than 2 psi, even that's kind of high in your suction line, or you got a plugged filter dryer or something's plugged inside that suction line. You need to fix that. And as a technician, you need to understand the whole system. You need to understand how to size lines. I never really knew that. I sized some systems when I was a technician in the field, but most of the time it was sized for me and I went and installed it. But as a technician, you want to be good, you need to understand the size of those pipes, because you need to understand the velocity going through the pipes, so you can understand the mass flow and understand how all that works. Okay, let's keep going. Okay, always check your discharge line temperature. So many technicians do not do this. You need to check it. 6 inches, 150 mils away, and you're looking for 225 is a good range. Compressors run at 225. It's usually lower than that depending on the application, but 225, you're okay. When you start to get 300, 350 degrees Fahrenheit or 150 Celsius, you're starting to stop lubrication or lose lubrication. And then you start to break down the oil, causes major issues. And then any temperature increase in your suction is same increase in your discharge. So now if you have suction gas coming back hot, you don't insulate your suction line, or you have insulation that's really old, like 10 or 15 years old, and it's going through a hot attic or a hot space, even though you have insulation, but if it's bad insulation, all that heat could be coming back to the compressor and causing damage, overheating the compressor, causing them to fail. And these compressor manufacturers make good compressors. It doesn't matter which one it is. They all make really good compressors. The large manufacturer like Bitzer, like Copeland, like Danfoss, like Tecumseh, they make good compressors. The problem is that we break them or the customer breaks them. by not doing the maintenance, by not servicing a product, by not installing a product. Compressors should be lasting 10, 15, 20 years, not 2 weeks, not 6 months. And the next thing, overheat prevention. Okay, always maintain that compression ratio. Every compressor is going to have an operation envelope. So down on the left-hand side, you can see this one's a ZF scroll compressor from Copeland. That's the operation envelope of this one with those specific refrigerants, because it's going to change per refrigerant. And then it's going to tell you if you need injection or no injection or head cooling fan. The one on the right side is a Bitzer operation envelope. And this is what you need to start understanding is where's the system running inside these envelopes? Because if you don't, and it's running outside, like kind of putting the low pressure control, setting it for, 1 PSI or 5 PSI or, a half a bar. And, your limit of your compressor is higher than that. You don't want to go lower. Sometimes you don't want to go lower than 1 bar in that compressor. You're outside the envelope, or 15 PSI. That means you're running outside the envelope. And if you run it like that for a long period of time, cause work and you reduce the life of the compressor. So set the low pressure, learn how to set up a low pressure control property to the manufacturer's, compressor manufacturer's envelope. Suction pressure drops real bad. Add additional cooling. Do you need to add injection to the compressor? Head cooling fan. And with these new refrigerants, 448, 449, all these new refrigerants that run way hotter than R22, 404. So you need to check with the manufacturer. Do I need injection? Do I need a head cooling fan? So do you want to launch that poll, Vanessa or Sergey, please?
One moment.
Thank you. And if you have any questions, just throw it in the chat or the Q&A. You want to check the Q&A right now?
Yeah, we've already got some questions there.
So the first question,
Okay,
while the poll
started.
Perfect. So the poll question: what usually causes a spot burn in a compressor? A burn through the motor winding, dirt in the system, or mechanical damage, relays, contactors, capacitors, wiring, lead terminals, or short. So just answer that question. And I talked about it in the very first slide. What usually causes a spot burn? And what a spot burn, if you pull apart a compressor, it's going to be like right in the winding. It's going to be it kind of looks like a little explosion, a little burn pattern right in a single spot. And they could be really big as well, but right in a single spot. And then I see 60% of you are saying dirt in the system. Exactly. Dirt in the system, piece of copper, you're reaming out the copper and it makes its way back to the compressor and it causes a spot burn. Or you get a slug that happens, it breaks a piece of the suction reed and it goes into the windings. So I got a question here. The basic function of a vapor compression system. So what happens? The compressor starts up. So you get energy to that compressor and the compressor turns over, single phase, 3-phase, not going to dive into that. But as it starts to pump, you got a piston right here. As it starts to pump, inside the chamber, it builds pressure up. So it sucks in the suction gas. And as it starts to compress, it squishes that gas, building pressure up. And so that pressure is built up and pushed out the discharge line. And then from the discharge line, you have de-superheated gas going out to what we call our condenser. There's 4 components: compressor, condenser, metering device, and evaporator in your system. And so as it goes to the condenser rejects heat and condenses that vapor refrigerant into a liquid. And then that liquid goes to a metering device. The metering device could be a TX valve, electronic TX valve, capillary tube, which reduces the pressure. The way refrigerant works, you increase pressure, you increase temperature. You decrease pressure, you decrease temperature. So as that TX valve or metering device reduces the pressure, flashing into the evaporator, that evaporator is absorbing the heat from product, from people. And then from there down the suction line, you should have vapor gas going back to the compressor. Hopefully that answered it. How contaminants add to the system, even system fully protected with a liquid side filter. So contaminants are added by not pulling a proper evacuation, reaming or sanding sandcloth. I've done it before. You're reaming out the thing and you're doing it vertically, and a piece drops down in there. It only protects so much. Because even at the filter, because it's on your liquid line, if you're doing on the suction line, you don't have a filter all the time on the suction line. So that's how it happens. And what causes gas to blow off? Okay, gasket. So it could be compression ratio that cause it. Heat causes the gasket to wear. A slug is the big one. So all of a sudden you have a slug happen. And we're going to talk about that here in a second in flooded start section. So other prevention, high superheat. Make sure if you have high superheat coming back, that could be causing your overheat. Maybe your TX valve is not opening. So grab the bulb, grab the TX bulb, and you should see that refrigerant should start going through because you're heating up the TX bulb because that TX bulb is pushing on the pin to open up the valve. It's a whole nother subject, but grab the TX bulb and you should start to flood that evaporator. If you don't, maybe there's something going on with the TX valve. You could have an undersized TX valve. You could have a plugged TX valve screen because you didn't properly purge. Lots of different things that you need to check. Solenoid malfunction, high superheat leads to high heat. Okay, let's go. So flooded starts. What causes a flooded start? So compressor's off, nothing's running. You have an accumulator. Oh, accumulator's protecting the system. Well, the accumulator only protects against flood back. And you need to understand this because if you add a accumulator as a band-aid and not see what's going on with the system, you will run into a lot of other problems. So the system's off, the accumulator has a bunch of refrigerant in it. But the compressor's colder, we'll say. If that compressor's colder, that refrigerant's going to want to migrate. So, sorry. So this migrates as a vapor into the compressor. Now, all of a sudden, the compressor starts to fill up with refrigerant because it condenses in the oil. So if you ever look in a compressor and you look at the sight glass and it's filled, that's a bad sign. More oil is bad. So because you could be refrigerant under there or too much oil. So you need to understand that. And then all of a sudden, this compressor is full of liquid refrigerant. And then bam, you get a slug. Or this is a flooded start. You know, a slug is when you break something. If you don't break it, that's called a flooded start. You need to know the difference. And then once again, if the compressor is off, depending on how much refrigerant in the specific compressor and a specific application, it could be coming back your discharge line out of your high side. And bam, you get a flooded start or a slug. You may need a check valve. So this is why it's so important to go to those compressor manufacturer guys and find out if I have 7 pounds or 10 kg in my system, do I need a check valve on my discharge line or not? And this is the research you need to do as a technician. Boom, because this is what happens. This is a flooded start. If you open up a scroll, and the way to open up a scroll, you need to 1/4 inch below or 10 mils or 20 mils below the weld mark seam along Copeland compressors. You cut around there. You got to do it safely. Safety glasses, shield, gloves. You can use a sawzall or a zip cutter, a reciprocating saw. And you cut around it, you take it off. But this would be this section here. So this section here, if you look inside the compressor and you see this here, scroll galling just like this, that means you had refrigerant go up there, wash the oil out, and cause that metal on metal. You're not going to get oil in there ever again. If it looks like this is a flooded start. I mean a slug, sorry. Because you're breaking the scroll sets. So flooded start prevention. Okay. Install a crankcase heater, install it properly. If any of you caught it on the very first slide when I was talking about low oil, you've seen 2 of these crankcase heaters on there. And one was above the sight glass, so bad. You need to put the crankcase heater on where the compressor manufacturer tells you. Because if you put it too high, it's going to overheat that compressor and cause a failure. And it needs to go in a specific place. So here's a seam. You need to make sure you put this on here properly and you torque it right. Because the crankcase heaters are going to fail prematurely if you don't install them right. Set up a pump down cycle. Pump down cycle is where you shut off a solenoid, we'll say, and it pumps all the liquid refrigerant out of the evaporator and all out of the suction, so you don't have any migration from the evaporator to the compressor. Do a bump start cycle. Bump start cycle would be, you can add, there's different components out there where if the compressor's off for longer than 5 or 6 hours, you know, the ambient's a certain temperature. what it'll do, it'll start the compressor up for 2 seconds and then shut it off for 15. Start it up for 2 seconds, shut it off for 15, and so on. Different manufacturers have different times, but what happens, it flashes the gas. So instead of having a slug, you'll have more of a small flooded start happening to boil off that liquid refrigerant. And a must read is Copeland AE 221182. You need to read this one. This is a a guide talking about controlling liquid refrigerant and refrigeration and air conditioning system. You need to read this one. I did a podcast with Brian Orr from the HVACR school. Listen to that podcast. I talk about this whole manual because it's important to understand if it's a floodback, flooded start, slug, whatever it is, you need to understand, or oil issue causing that issue. So floodback is the next one. Any questions? Let me just check because I know I'm going through a lot of stuff here because I only have so much time. I had a system where the evaporator superheater was 8 degrees F, but when I checked at the compressor, it was 55. Line set was very long, old bad insulation. It was burnt. In this case, should I have flooded the evaporator? No, you need to fix the line set. So in that it was the suction line sized properly. Because if you don't have the proper velocity going through the suction line, you're not going to be moving the gas properly to cool the compressor. Because if it was a refrigerant cooled compressor, you need that gas to cool the motor. And because either the line set was bad or that suction line with bad insulation was running through a heated space, picking up all that heat. So you needed to replace all that insulation. So hopefully that helped. Because if you're flooding the evaporator, because each evaporators have a specific superheat that it works the most efficient and effective. So you need to talk to that evaporator manufacturer and find out, should I be doing it at, 8 degrees Fahrenheit, 5 degrees Fahrenheit, 10 degrees Fahrenheit, 2K, 4K, 6K, depending on the manufacturer. They'll tell you what the most optimal superheat is for that evaporator. If you reduce the evaporator, you're just putting a Band-Aid on, reduce the superheat, you're putting a Band-Aid on the system. There's a design flaw there if the suction line was too big and you don't have that velocity come back to cool the compressor. Okay, floodback. Compressor is running. And this is when you have oil, everything looks good, everything's running good, but boom, liquid refrigerant starts to return to the compressor while it's running. That evaporator is not boiling off the refrigerant. And this is a great segue to the question that was just asked, because now if you're flooding the evaporator, that liquid may make it back to the compressor. This is where there's no superheat here, 0K, 0F right there. And it sometimes looks like this. But even if it looks like this, you don't always know. You need to check your superheat. You need to put your gauge on there. You need to put your temperature probe to figure that out. And this is what a scroll would look like when you have floodback. Right here, right inside here, it's going to be damaged real bad. On semi-hermetic compressors like a Copeland 63D40, you have to pull off the oil pump. And you need to do some shake hands with the crankshaft. If there's a lot of up and down play, that means your main bearing is wore because you have something called progressive wear. Kind of like that very first picture that I showed you. Floodback prevention. Set the superheat properly accordingly. You need to check Bitzer manual. You need to check Copeland manual, see what they say. They're a little bit different, but not by much. I always say 20F or 11K back to the compressor. That's enough cooling. You're not overheating. You're not flooding. Could it be 15 Fahrenheit or 9K? Sure, it could be. It's still, as long as that you check it at every load, every condition, that it's not flooding back at all. And then CO2 compressors is totally different as well. So you need to look that stuff up and make sure you're checking that. Always maintain proper airflow, because if you're not boiling off that refrigerant or absorbing the heat in the evaporator, the fans aren't running, you got honeycombs dirty, you got evaporator plugged, you got it ice up, you're going to run into a lot of issues. How am I doing for time, Vanessa? I know I'm talking a lot here.
Yeah, I think we have maybe 10 more minutes.
I got 10 minutes? Okay, excellent. Okay.
Maybe next poll, the poll?
Oh, sorry, yeah. No, the poll comes up on this one, so you can launch it if you want. System checkpoints, and this is mandatory. You need to be doing this every time. I know you can get complacent. I've done it You know, you go up to a system, you touch it with your hand, you know what I mean? And you look at it. I've done that before. If you want to be the best technician out there, best technician at your company, or best in your organization, you need to do all these checkpoints and get used to doing it. This is your job. And when you start doing these checkpoints, you can tell any refrigeration expert the checkpoints you check, and they'll be able to tell you what's going on, because they can look at it, they can see what's going on inside the system, and they know the numbers. When you know the numbers, you know what's happening. And this is from refrigerant temperatures, pressures, and electrics, amps, volts. When you know all that stuff, it's easy. Your troubleshooting gets a lot easier. Things you need to check. So suction pressure, need to check it. Suction temperature, every time, these two, because you can get your superheat back in your compressor. Discharge pressure, discharge temperature, mandatory. Anytime you're doing a troubleshooting, you need the numbers. You need the numbers. You can't just say it's good. Putting your hand on it, oh, it doesn't feel like it's burning. You know, and I was taught by a journeyman, oh, if you spit on the head and it starts to boil off, then you know it's overheating. That's not what you do. You use your gauges and tools. That's what they're for. If you want to be the best. So condenser air in, condenser air out. What should it be? So this here is called the delta. And then there's a TD. So you need to understand the differences between delta and TD. For me, it's the room temp. For the TD, it's the room temperature and the SST. That's your TD. Okay. Then you need to get your subcooling at your condenser. Every time you got to check what's that liquid coming out, because you need to make sure you have a full column of liquid leaving that condenser. Okay. You need to check your temperature in, check temperature out of your filter dryer. You could do pressure as well with temperature work. You get 1, 2, 3 degrees. There's blockages happening because there should be no temperature difference through it. You start getting temperature difference, that means your filter's plugging up. You need to check if there's moisture or bubbles in the sight glass. So important. You need to check your subcooling at the inlet of the metering device. Did the temperature change? Did the subcooling change? If it did, what's going on in the liquid line? Is that filter dryer plugging up? You need to understand that, because now you're flashing at the TX valve potentially, and that's an issue. You need to check the air in, air out of the evaporator. Then you need to check your TD as well. So that's your room temperature and your SST. You need to get your superheat at the outlet of the evaporator. So important to get it there. You need to get your suction pressure in, suction pressure out. This is your suction line. If you have a suction filter dryer, you ever walk up to a system that has a suction filter dryer, especially on a condensing unit, refrigeration condensing unit, someone usually added that there. It's not supposed to be in the system. It's usually for a burnout. If you have a bad electrical failure, you add it to clean out all the acid. But that should be removed after 48 or 72 hours. You go check out Sporlan, you go check White Rogers out, you go check Danfoss out. They're going to tell you, they want you to really remove that afterwards. Are there permanent replacements? Yes, there is. You can have larger systems with filters on it, but you need to change that if you got a pressure drop. And then the last one is that the compressor superheat. You need to do these every time. When you start doing these every time, it's going to get easier. You also need to do your volts, your amps, and things like that. But you need to do this to be the best. And when you start getting this, it's going to get easier. You're going to be able to start seeing inside the system and understand what's going on in the compressor, in the condenser, in the evaporator. Super important. Okay, polling question. You want to launch that polling question, please? Or did you already launch it? Oh, you did. Okay, which of the following thermostatic expansion valve conditions could lead to compressor floodback? So 17 of you got it right. All of the above. You know, poor or loose sensing bulb. And I've seen this a lot. I just don't tighten it properly or tighten it too much and break the sensing bulb. Okay, plugged or disconnected external equalizing line. That external equalizing line should be downstream or past the bulb. So it knows exactly, and you'll see these on refrigeration condensing units with evaporators with distributors on it, because there's multiple circuits. So it wants to make sure it knows exactly the pressure for all those different circuits going in there to tell that TX valve what's going on. If that's plugged or installed wrong, or you cap it, you're going to run into major issues. And then something plugging it, like copper debris plugging the metering device. Great job on answering that question. Okay, mobile apps. Not going to go through them. If you don't have these apps, you need them. You need these apps. So if you're in North America, AE Bulletins, in Europe, This is for Emerson. In Europe, you may have to go on to the Copeland software, Copeland Select 8. I'm not sure if they have AE Bulletin. They may have it in Europe. I'll go check that. Bitzer, B-Spot, you need that app. Danfoss Ref Tools, you need that one. Copeland Mobile, you need that one if you're working on Copeland compressors. So really, it depends on what you're working on. If you're working on always Bitzer, you need that one. If you're always working on Danfoss, you need that one. But I highly recommend getting them and learning them. Because when you start learning all the manufactured compressors, you're going to start to see lots of the things that are so similar from all the different manufacturers. That's going to make your job so much easier. Next, educational resources. You need to be following people out there that's sharing knowledge. HVAC School, HVACR videos, HVAC Know-It-All, Toolshed, R744, Friends from Atmosphere. All this is resources that they're sharing knowledge. So you can become better technician, better engineer, better refrigeration professional. Okay. See if there's any questions here that I missed. Okay, I'll get to these questions in a second. So that is it for talking compressors. So that was a quick snippet of what I do is compressor training. I got a compressor masterclass coming up this Saturday, and I highly recommend if you want to become an awesome technician, understand compressors in and out, starts November 27. And it's important. As you talked about, I just talked 25 minutes straight, quite fast, but there's a lot to know. I didn't talk about, torquing them, the right gasket. Which gasket do I pick? Do I need a check valve? Do I not need a check valve? Should I use a semi-hermetic in this place instead of a scroll? And all that information all goes back to compressor training. Compressor training leads to all the system diagnostics. I hear lots of people, well, I need advanced control training, or I need specific high-level training. To be honest, I learned the most from going right back to the basics of compressor training, inspection, and field diagnostics to become an expert at refrigeration, and all because of compressor training. So it starts November 27th. It's a 4-week program. You're going to have 8 hours over the 4 weeks. So 2 hours each week with me talking about compressors, learning how to troubleshoot, learning how to install them, to be the best technician or engineer. So I'm super excited about this program, and it starts on November 27th. Okay. If you're interested, I know Sergey is going to put the link in the chat. Next steps, sign up for the program. That's it for me. So sign up for the program. I'm going to answer a couple of these questions when we get to them. I'm going to stop sharing here as well, but there's the link there. If you want to check out, read more about what my program's all about, go to that link and find out a bit more. Sergey, that was a lot.
Trevor. Thank you very much for your presentation. Dear friends, please follow by link in the chat and learn more about Trevor's course.
Yeah, thank you very much. It was really informative. Yeah, and we will move on to the questions a little bit later. We will have the QA session. Yeah, and right now we can move on to Maxime, to our second speaker. So I pass on the word to you, Maxime.
Welcome, Maxime. Join our webinar.
Yes, wait a second. So, good afternoon, everybody. Thank you that you're going to listen to me, and I will try to briefly describe one case which is illustrated what Trevor already said. And for example, I am his former colleague. I'm also worked for Emerson for 7 years. And this case I would like to describe is connected with scroll compressor, ZB series. And one time I got from the client the following compressors. And as you could see, these marks, this is a bearing, and these marks. And everything that I get from the customer, it's look like lack of lubrication. It's maybe connected with different reasons, but for me, it was just simple case. I just said it's lack of lubrication and so on. I thought that case is closed, but it was not the truth, because customer have some points. One of them, traces of the bearing line failure are clearly visible, and working surface of eccentric bushing. It's okay. And as a result, working surface of the bearing upper corner due to chips we got. Other parts have no wears, and moreover, they will install level regulators like OM3 and something like this. And according to customer point of view, there was a manufacturing fault. Okay, I asked them to send me a date from monitoring system. I got the same, the following date, and this color is indicated superheat. I spent several hours to study this data, and I mentioned that sometimes superheat goes lower than 5K. After that, I asked to send design of the unit from the customer. I got this, and from the first look, it's looks okay. It's a suction line and discharge line. It looks okay. After that, I asked him to send me a PID, and I noticed that pressure sensor was installed directly on a suction header. Okay, next step, I asked to send PID of cold room. I got it, and I noticed that there was installed electronic expansion valve. These 2 points, what I noticed, means that one pressure sensor is used for both for capacity control and for superheat control. And what it means? It means that when we measure superheat, the real value will be less, because the superheat is a difference between suction temperature and saturated temperature, which calculated by using value of pressure. If we measure pressure by sensor installed directly on evaporator, it's okay, we got real superheat. But if we measure by using pressure sensor installed on a suction heater, maybe several meters long from evaporator, it means that we have pressure drops, and in real saturated temperature will be lower, and that means the superheat will be lower and evaporator. Then I already know what to say to customer, but I asked him to send me a picture of a cold room piping. And what I noticed? I noticed that this is evaporators, this is suction line, and this is suction heater. And as you can see, there is no trap. And it means we have 2 points. We have lower superheat, and when the temperature is decrease and the solenoid valve or electronic expansion valve closed, we have number of liquid in each evaporator. And because this pressure is higher on this point, all liquid goes to heater and then go to compressor. And that's why reason that we have lack of lubrication. And just after that, this case was closed. So thank you for attention. I just my example just highlight what Trevor said, and why understanding of compressor is very important to understand and to find a real failure of refrigeration system. Thank you for attention.
Thank you very much, Maxim. Okay, let's start session Q&A. Maybe Trevor will start. please
Yeah, for sure. I see a
please
couple of questions.
check the section Q&A.
Yeah, so the first question is from
And
Mo.
comment.
So, yeah, why compressor manufacturers do not install oil cyclasts to seal compressors, allow technicians to seal oil? Great question. The big thing is the cost. Right? It costs a lot of money to manufacture those compressors with a cyclast, especially the smaller ones. That's why you don't see them. And as a technician, oil used to be the hardest thing to troubleshoot. But when you understand what's going on in the system, understand the piping, just like Maxime just talked about, you don't need a cyclast all the time because you will understand what's going on there. And then if you replace a compressor, you measure the oil in those ones. But the main reason is cost, right? Because each manufacturer want to make the highest quality compressor at the lowest price because it's a competing industry, right? So it doesn't matter if it has a cyclast or not. You just need to understand what's going on in the system. And over time, when you gain experience, you're going to be able to understand that. And the big thing is measuring the oil and matching it up to the compressor specs, compressor manufacturer. Next question. How much of a pressure drop will we get in a condenser when from discharge line to liquid line? Well, that's going to be depending on the condenser manufacturer, right? And it's going to depend on the piping, the lines, the sizing. So I can't really give you an answer on that one. So sorry about that. Next one. It is important to do measurements in the system, but to measure pressures in many points is often impossible because you haven't had Schrader valve. Great question. On smaller systems, yes, you're not going to have it. But what you can do is take the temperatures everywhere. And most manufacturers will give you an idea of what it should be like. And then over time experience, when you continue to take the temperature everywhere in that system, you're going to see, well, my discharge temperature is higher, my suction temperature is higher than what it is. Is that metering device feeding properly? Is the condenser dirty? Because if you have a dirty condenser, you're going to have a higher discharge pressure. If you have a dirty condenser, you're going to have a higher suction pressure. If you have a dirty condenser, you're going to have higher amps. And when you start to understand this and you start to learn what's going on in the system, it's going to make it easier. So you don't always, it's better if you have the Schraders, but follow up with the manufacturers. I find a lot of technicians don't do this. They don't reach out to the manufacturers, look for their specific manuals, and it takes research. It takes time. First time you're going to get frustrated probably because I spent years and years of researching trying to figure this out. But they usually have pretty good manuals because they want their equipment to run for a long period of time. So you come back and buy more of their equipment. So take the temperatures if you can't get the suction pressures or discharge pressures.
Yeah, thank you very much.
Thank you.
Yeah, please ask more questions. I can see 2 new ones.
Okay. Why some manufacturers put service ports on discharge line, but not on the liquid line? And then the top. So that is up to the compressor manufacturer themselves. Once again, it's probably to reduce costs on their systems. The big thing is though, you need to find out what the sequence of operation is, as well as their troubleshooting sequence. Most manufacturers, once again, go to their bulletins. They may have an installation manual, but they may also have a service manual, and they may also have a troubleshooting manual. And sometimes it's hard to find. You need to do that research. Once again, that would be most likely cost. That's why they don't add all these extra ports. What is the difference in air-cooled and water-cooled condenser when overheating? Well, really, it's the same things happening. You're overheating the compressor. Either you're not getting the right cool water, the gallons per minute flow across the compressor to cool it, to absorb the heat or suck the heat out of the compressor. And air-cooled compressor, you might not have enough air blowing over it. Or with these new refrigerants, you may need to add a head cooling fan. And I've seen this on hundreds of occasions working in supermarkets. I'll walk in, low Temperax running, R22 system. All the compressors running, only 3 fans are running. When you see that, that fan needs to be replaced because you need that airflow over the compressor to cool it down. And it's no different with these new refrigerants. They don't run as hot as R22 in low temp, but they run hotter than 404. So you need to check the specs of the manufacturer so you got that airflow. So refrigerant cooling the compressor, as well as a fan blowing over the compressor, as well as adding injection if you need it. Very important. That's on the air-cooled, refrigerator-cooled compressor. Water-cooled, it's the same thing. You just need to make sure you have that right inlet temperature of it. If you have really hot water going to try to pull off the heat, well, you're probably going to run into issues. If you don't have that flow, that water regulating valve, if it's not set up properly, you don't have enough flow, you may overheat it as well.
Okay, thank you. Let's check some questions from the chat.
Awesome. Okay, yeah, let me check here.
I will try to read.
Okay.
Please. Flooded starts related to refrigerant issues only.
Flooded start related issues only.
I will repeat the question in the chat. Okay.
Okay.
Please read the.
Flooded starts related to refrigerant issues only. Well, flooded starts, as I talked about, is that refrigerant migrating back to the compressor. So refrigerant is chemically attracted to oil, POE oil. So it wants the refrigerant wants to go to the compressor because the most oil is in the compressor, but it also wants to go to the coldest position. Refrigerant's going to travel through the system to get to the coldest part. And when you do not set up crankcase heaters when they're needed, when you're outside and it's below minus 20 Fahrenheit or minus 20 Celsius, you need a crankcase heater to heat up when that compressor's off to make sure you keep that oil warm so that refrigerant doesn't travel there. You may need multiple heaters depending on how far close to the Arctic you are. Yeah, and it's important to understand that. And you may need pump down. So what I mean, you shut off the solenoid valve. So like I talked about, you don't have any liquid in the low side. Okay. Hopefully that answered your question.
I have one question from our website from registered participants.
Awesome.
One I will write in the chat. Please read.
When does oil foaming in the compressor? Okay, great. So oil foaming happens multiple ways. It can happen on startup. If the compressor starts up and it rocks and is bang and all of a sudden it foams up the oil, that's a flooded start. There was oil in that refrigerant and a massive explosion, okay? You can also see foaming during floodback. So the compressor at this point is running now and all of a sudden that liquid refrigerant's making its way back and it starts to boil off into oil. And then all of a sudden you'll start to see the oil levels start to drop and you get more foam, more foam, more foam. And then there's only foam in the sight glass. That's usually flood back. So that's when you'll see foaming in the oil. You need to understand the differences. Which one's flooded start, which one's flood back. And you could potentially have both of them. The compressor starts up, it bangs, and all of a sudden you see the explosion of refrigerant and oil. And then all of a sudden the compressor's running, and then you continue to see foaming of oil till there's none left. And then you have lubrication issues.
Thanks. We need to finish. And please, last question. Share with your opinion about new CO2 compressor, scroll compressors from Emerson.
Okay, awesome. Yeah, so I've learned lots about them, and I heard about them for a long time, and it's going to be a great technology to use out there for smaller platforms that I understand. They're going to continue to grow that platform, but I think it's going to be a great technology. Myself personally, I haven't worked on any of those yet. I'm excited to get a chance to, but you're going to see a lot of different areas around the world start to use this technology. Smaller size, less weight. It's going to have the economizer ports. So you're going to see it in specific application. Will it be in all applications for CO2? No, but you'll see it in certain specific applications for it. And I think it's a great technology. There are other manufacturers that also have them. So just do some research and try to find that out as well.
Okay, thank you very much. And I would like to remind to everyone, if you want to learn more, please join to Trevor's course.
Yeah, for sure. Thank you.
Please find the link in the chat.
Yeah, like this was 20 minutes. and there's a lot of knowledge in compressors. I'm hopefully you learn one or two things over the last hour, because it's important to understand this as a technician, as a business owner, to be the best and do top quality work for your customers.
And don't forget, dear friends, don't forget to follow Refrigeration Daily News on our website. Please register and subscribe by a link in the chat too. And you can find on our website new refrigeration companies, refrigeration equipment, new suppliers. Please join to our website too. Thank you very much, Trevor. Please, Vanessa, your final words.
I'm very grateful for you being here. Thank you very much, Trevor. We're very grateful for all the speakers being here, attendance. We had very active people here, a lot of interesting questions. Yeah, so thanks for attending this webinar. And
it was great.
Yeah,
Thank
I
you.
think it was
Thank
great.
you for having me. This was awesome. I love talking compressors, love talking refrigeration. So appreciate you.
Hope to see you, everyone, in the next hour webinars.
Awesome. Yeah, I think it was really useful and productive. So thanks
Bye.
to everyone.